So here we have a cosine and a sine. They're not both even powers, so no half angles. So I want to peel off a cosine. So make it cosine to the fourth of x, sine squared of x, and peel off the cosine of x. And that's what's going to make my good du. So du is cosine of x, u is sine of x. Okay, so this is what I want to make work. I want to make the u substitution of sine of x work. Oh, look at that. That'll be taken care of. Again, this will be taken care of with the du. What am I going to do with that? So I would need to rewrite this as 1 minus sine squared x squared, right? Cosine squared squared. And then carry the rest of this along. Okay, so now let's go all to x's, all to u's. So I have 1 minus u squared squared, u squared, and then a du. So you know how to multiply this out, right? So this would give me 1 minus 2u squared plus u to the fourth. Then I would multiply by that, right? Lots of algebra. So u squared minus 2u to the fourth plus u to the sixth, because you add the exponents, right? So then I would get 1/3 u cubed, 2/5 u to the fifth, plus 1/7 u to the seventh. And then you would put the x's back in, which were this sine. So 1/3 sine cubed of x minus 2/5 sine to the fifth of x plus 1/7 sine to the seventh of x plus a c. All right, so let's go back and just got a couple more here. Oh, one more. So here we have a problem with sine of ln of x. So this is a type where you're going to have to think about, there's only two functions here. So one of the functions is sine of ln of x. So if I'm thinking about what I know the derivative of, I know the derivative of sine of ln of x. So careful, this is all one function. So the dv is just the dx. So that means v is x. And let's be careful taking the derivative of this with chain rule. Cosine of ln of x over x dx. All right, so let's carry the original guy along. Equals uv. So u v minus the integral of v and then du. Let's see what happens in here. X sine ln of x, that just carries along. These x's cancel, so I get integral of cosine of ln of x. Let's think about how similar or different this is from what I started. So it's not worse, but can you see that this is really similar to this? So what I'm going to do is I'm going to do parts again. I'm going to let u equal the cosine of ln of x, the dv equal dx, v is x, the du is negative sine of ln of x over x dx. Sorry, that got kind of cramped there. Okay, I'm going to go up here. So, because I need the initial problems. This is one of those you just need to recognize as those wraparound, that type 3 of the integration by parts. All right, so I start carry this original problem along. X dx equals this, right? X sine ln of x. And then I have a minus. Okay, so now I'm doing the integration by parts here, right? On this thing with these things here. So I get minus, and make sure you carry the parentheses along. uv, so I have x cosine of ln of x minus the integral of v du. So minus the integral of minus x sine ln of x over x and all the dx. Okay, let's be careful with all these negative signs, right? So let me just write out x sine ln of x minus x cosine ln of x. Erase this so we can see what we've got here. So when I cancel these two x's, and then I see I've got a negative and a negative and a negative. That makes a negative sine ln of x dx. Okay, well, what do I do with that? This is the exact same thing that I started with in this question. So I'm going to add that to both sides. So I'm going to say add that, add sine of ln of x to both sides. Add sine of ln of x dx to both sides. This gives me two of these guys, right? Sine of ln of x dx. And then what am I carrying along? These guys, right? X sine ln of x minus x cosine ln of x. And then I divide through by the 2 sine of ln of x dx. Gives me a 1/2 x sine ln of x minus x cosine of, so messy, sorry about that. Cosine of ln of x plus c. And that's the answer.